All right, here's another video where I want to share with you a real life work scenario that we basically ran into where you will design something for a system, and if you don't have enough information up front, you will design something bad, right? You will make a poor design, and when you deploy it to production, you will start running into issues where if you just knew a little bit of information up front, you could have designed it better. Now, we like to follow agile processes at work, and that's kind of fine. Like, design the system you think will work, get it in front of users, and when it starts falling apart, you redesign it. But I think this will be a really good lesson to like make sure you're asking the right questions during your sprint planning and like try to get realistic data numbers. Okay. So let me give you some background information. I'm going to talk in abstracts, but imagine that you're working on a system that has a bunch of online classes and you have a bunch of students. And every student can be assigned to various classrooms. And the average use case is like you have a student, maybe they have 5 or 10 different classrooms. And let me kind of walk you through a scenario that kind of maps to what we're doing at work. So let's say you have a student down here. We could just call it a user. When the user basically updates their address, we have a use case where we have to basically figure out all of the classrooms the student belongs to, and we have to generate PDFs. So let's just kind of draw this out. When a user basically updates address, what we need to do is the user makes a request to the API. The API needs to loop over every single classroom, and it needs to generate a PDF and store that somewhere. So let's just go ahead and type in like icon S3, and I'll just go ahead and draw an arrow, and I'll say like create PDF for each classroom. And we kind of like generate that PDF and put it on the classroom data model. It doesn't really matter how that works. The important part is that we thought and we designed a system where we didn't think a student could have that many classrooms, right? This process takes, 5-6 seconds to loop over all their stuff, generate PDFs using Puppeteer, stores them in S3, and then finally it'll update all the classrooms to basically have that new student address saved as PDFs a part of that. Now, this works fine, but what we didn't realize is that when we deployed this to production, there's actually some students who have thousands of classrooms. Now, again, I'm talking in abstracts, but this scenario can kind of apply to any system, right? You'd think that you have a certain amount of criteria when you start designing your solution, but it turns out when you get to production data, there are edge cases where there's real users that have real life reasons of why they have so many classrooms, and sometimes there's nothing you can do because it's just a business requirement that you have to basically handle. So one thing that we're planning on doing to make this more performant for those small set of power users that have a ton of different classrooms, we have to do some type of fan out, fan in logic. So instead of basically having this API loop over every classroom and generate PDFs, one solution that we're actually going to try doing is instead of looping over the classrooms and generating the PDFs inside this API, which again has like a timeout of like 30 seconds. What we're going to do instead is we're going to publish a bunch of SQS events. I'll just go ahead and say like send SQS event to generate PDF. Okay, so this could potentially send out thousands of these, right? For a single user who updates their address, this could send out thousands of SQS events. And then what we're going to be doing is down here, we will make another Lambda. We'll just call this like PDF generator. And basically this thing is just looking for events and consuming them. And every time it gets an event, it's going to process whatever data it needs. I'll just say like consume events, generate PDFs. Okay, so instead of this thing all being here, let's just move this down here. I'll say store PDF in S3. Okay, so the reason this is a much better and elegant solution is that this stuff can automatically scale up as fast as possible to consume all of these different events, generate PDFs, and just store them in buckets, right? So technically these things could be like scaling up under the hood, and you could be making tons of different Lambdas to process these events. And now we're not kind of stuck with our previous solution where like we'd have stuff time out because some students just had way too many classrooms and you couldn't just do a traditional for loop and just loop over those. Now you might also say like, why not just do it in parallel in the API? Well, the library that we're using can only do one PDF at a time. If you try to do multiple PDFs at a time, it burns up all the memory on the Lambda, and it also starts throwing some weird like binary exceptions because like a process has a lock and stuff. So again, this was a potential solution that we're going to try implementing at some point, which allows you to basically fan out. So like you have a process that you need to do a lot of work on, you fan it out and do a bunch of parallel processing. And then when everything is done, you basically fan that all back in and you let the user know when it's done using some type of asynchronous event, right? So like you could do like a WebSocket event, WebSocket, everything. Now, there are some nuances to this in our system because some of the users can't actually even use WebSockets. Like they're not allowed to use WebSockets. So you have to do some type of long polling or figure out a solution for that. But yeah, that's kind of one way that you can basically try to do a lot of work in a lot less time. And Lambda is awesome because like you just send it events, it just scales everything up for you automatically. S3 is an infinitely like large storage location. You can just keep putting PDFs in. We also use Dynamo. So like as these events are being processed, we kind of like store off these Dynamo events, which is great as well. So we can kind of keep track of like, when is this thing about to be done? Like, okay, it's on event 1000 and there's 2000 left. And that's kind of how you can build like a distributed parallel system that processes this stuff really fast. And someone did ask like, how long does this actually take? And I would say that we have a very similar system, and it usually takes about 2 to 4 seconds to generate a PDF. So if you're able to like make this all be in parallel and Lambda scales it up as fast as possible, you can actually do like thousands of PDFs in maybe like 10 seconds. So it's pretty cool. It can really like speed up your system if you really think about like parallel processing this way. Anyway, I think I just started rambling at some point, but I do think this is a good thing to share with you all, especially if you haven't like worked with larger systems with larger pieces of data or with larger data sets and stuff. But the main takeaway that I'm trying to get at is, when you're in your sprint planning or like your backlog refinement and you're talking about implementing a solution, one of the most important things I would ask is like, what are some accurate data points for like how many classrooms does a student have? And if someone can't answer that question, I highly recommend that you try to figure that out, because if you go from like 10 to 1,000, that can completely change how you need to implement your solution, right? And it's really important to make sure you have that stuff up front, because you don't want to like waste time building a simple solution, get it deployed, starts throwing errors for users, and then you have to basically, and that looks bad because your clients think that you implement poor solutions. Your users are upset because their stuff is just failing. You kind of have to like turn off your feature you just deployed. Hopefully you had a feature flag to kind of turn it off easily. And it's just, if you have more information up front, you can design these things much better. So that's the one piece of information I would take if you even made it this far in this video, is try to ask as many questions as possible to make sure that you're implementing the right solution for the feature. Other than that, I hope you guys enjoyed this little talk. If you did, give me a thumbs up, comment, subscribe, press the bell icon, and like always, I have a Discord channel you're welcome to join if you want to find a place to hang out with some other developers. Yeah, other than that, have a good day and happy coding.